I want to talk about your brain on AI and the kinds of things we can do to ensure that we're using it in a productive way for learning. I wanted to title it Brains, Bots, and Bullshit, but Josh was like, how about we go with something more professional? So I threw that on there, and we'll get around to what that actually means as we get into it. So I'm curious, who's recently used generative AI to learn something? Hand raises. Okay, so many of you, I want you to talk to somebody close to you. This is a meetup. I want you to share a story of a time that you have used generative AI to try and learn something. Make a friend. You have 2 minutes. All right, we will keep this conversation going. I want somebody to shout out something they learned or learned that somebody else learned. Yeah, go.
REST programming.
REST programming. Okay, what else? Yep.
Postgres database.
Postgres bots. Okay. But I learned how to cook something. You can do all sorts of things, right? You can ask it for information. And what I will hopefully convince you in the next 10 minutes or so is that you probably didn't do it as well as you should have. But there's hope, and you can do it better. And the reason I am optimistic is because I was a very traditional academic until I met some crazy people who were going to build a university from scratch. So for the last 10 years, I've been working with a group called Minerva. We built Minerva University. It has a really unique active education model and a global rotation. And when that got its own accreditation in 2021, a group of us started working with other universities around the world to help them rethink their curricula and their teaching practices so that college is more effective, more experiential, and more relevant for the 21st century. And in higher ed, everyone is freaking out about AI. They're like, my students aren't learning anymore. And my answer is usually they weren't learning before, right? So if your practices are not resistant to AI, you are doing something wrong. And I'm going to start to illustrate that with a couple of different fallacies that we try to address. So we talk about these a lot at Minerva in the work that we do at our own university as well as with our partners. And the first one feels kind of obvious. The first one is that exposure doesn't equal knowledge. We know this based on the science of learning. If you listen to something, it's not sticky. The times lectures work are when experts talk to other experts, when they can actually already understand the level somebody is speaking at. Usually you are not having that conversation. You're working with a novice. And so expecting them to read something passively, expecting them to listen to you stand on a stage, it's not getting in their heads. The second fallacy we talk a lot about is the fact that knowledge doesn't actually equal learning. And this one is weird. We think that if we have knowledge, it is something that we now own, and we assume that we have learned. But if you think about the real definition of learning, which is taking in information in a way that actually changes your behavior, so you do something differently in the world, just knowing something isn't enough to actually say you've learned. And so my CEO likes to illustrate this by saying that he bets in your life you have sat in a seat quite a bit like this and listened to someone give a talk and found them very boring. And it was very obvious for you to listen to me and say like, oh, she's doing this wrong, or I wish her slides were still there, or all of these things that you can really critique well. But all of you have probably gotten up in front of other people and were also boring. And so just knowing what something is or what it looks like doesn't mean you've learned enough to apply it. So this is an AI thing. This is not just a learning thing, and my slides are gone forever. So essentially what they find is that consultants are 40% smarter when they use generative AI. So they actually did a really nice experiment. Some people didn't have it, some people had it, and some people had it with an explanation of how to use it well. And so what you see, this is not my data, this is a group out of lots of different schools, some at HBS. So this is the distribution of work that was done without generative AI. And as you can see, if you get a tool, you become better. This is actually quality. So they're turning in better work. That's the headline. The subtitle of the paper that nobody really talks too much about is that it's disproportionately helping people who weren't good to begin with. So if we break down their data, we look at the bottom half of participants in terms of quality. They're getting quite a big boost. And people who are already good are getting a little bit of one, but it's not as large. So AI can help us do things better and turn in higher quality work. But if we're already good, it's not helping us that much. And the one that nobody talks about is that it also actively screwed up people who used it when it was designed as a task that AI wouldn't be helpful with. So the authors were really sneaky. They came up with something that would give the AI a hard time, that it would have the wrong answers. And so what you find there is if you don't have access to AI, you are about 84% accurate. But once you're given misinformation from AI, it actually hurts your performance. You turn in worse work. So it really is about how you're using this tool and whether or not it can give you reliable information. There's another more recent study out of Stanford where they look at collaborating with AI to generate creative ideas. Generative AI should be pretty good at this. Its job is to kind of make things up. And so if you're trying to ideate with it, it should help you. And it turns out it does in terms of volume. But what these people found was that AI-assisted teams produce more ideas. But when judges rated them, they were actually really normal. They were just fine. So they bucketed them into A ideas, B ideas, C ideas, and D ideas, kind of a grading scale. And when teams used generative AI, they got more ideas overall, but they were all sort of Bs. They didn't produce more A ideas. That came from real humans working together collaboratively without an AI assist. What I love about this study is that they actually also asked people how they felt about their own work. It wasn't just an independent rater saying, hey, I think that this is good work or bad work, the same way a teacher would grade you. It was asking performers about their perception of their own work. And what they found that I love is that AI-assisted teams with worse solutions felt better. They're like, we did great. And AI-assisted teams with better solutions felt worse. So the raters are looking at this and saying, that's pretty good work. And the person who produced the work with their group is saying, I don't know, that wasn't great. And exactly the opposite. If I'm thinking it was really great, other people are looking at it and being like, ugh, not that great. So they dug in and said, why? And the reason comes down to iteration. How much did they iterate and go back and forth with the tool? And what they found was that the AI teams who iterated less had worse results. They didn't press the AI, they didn't interact with it, they just said, sounds good, and they felt great about it. And the teams that iterated a lot, which actually led to better results, felt worse about their performance. And this is kind of fascinating because it mirrors exactly what we know about teaching and learning in lectures versus active learning classrooms. So which one is better? Anybody? A, raise your hand, or B, don't raise your hand. All right, perfect. Okay, so punchline, active learning is better for you. We know this from tons of studies, but this one's slightly less well known. It's one of my favorite findings in the entire world. So in a passive learning class, they asked students whether they enjoyed it, whether they felt like they learned, whether the instructor was really good, and whether they had a desire to repeat that kind of experience in other physics classes. So this is just kind of your baseline data in a lecture class. They flip it and they make students do active learning. And on every single metric, you get less good ratings. So active learning, we know, is actually better for learning. But students think they learn less. They think the instructor is bad. They don't want to do it again. They don't feel like they learned, and they didn't really enjoy it as much as they enjoyed sitting there and listening to somebody talk at them. And this flies in the face of what we actually know about active learning, which is that if you have a really hard class, there's going to be some percentage of people who fail. It's roughly normal. And if you take that class and you make it active, people are actually way, way less likely to fail. And it's because working with the knowledge makes it stick in your head. The challenge is working with the knowledge is uncomfortable. You're like, what the hell am I doing? Why do I have to talk to these other people? This feels really hard. And what we do is conflate that feeling of unease with the perception that we haven't actually learned. And so if we go back to that study where they looked at people's perceptions of the active learning classroom, what they did was they actually measured actual learning. And so all of these people who are saying, I didn't learn as much, are actually learning more than when they were in that passive learning classroom. So this kind of gets us back to this idea of your brain's superpower should be to learn. And it doesn't matter if you're talking about teaching and learning in a physical classroom, whether you're interacting with AI. The challenge is we've been conditioned against doing so. So what we know about the way the brain learns is not everything. And the ways that you would engage students can differ across different age groups. But the challenge is that your brain works pretty much the same way at all stages, and it learns through failure. But we don't like the experience of failure, right? So your brain is constantly making a prediction about what's going to happen next in like a millisecond by millisecond timescale. And you learn when you create a prediction error between your expectation about what happens and what actually happens. And I suspect that your younger kid is really excited because they're just sort of learning about books. And there isn't a lot of failure or feedback. And your daughter is frustrated because she's hitting a wall. But that's what she has to grow through. And so that's why you're getting results like this. It's like your daughter is in this study. Like, I find this hard, I don't want to do it. But you're not going to learn unless you actually try it. So there's a couple of reasons why we're conditioned against feeling like learning is good for us. And the first is that the school system is really bad. Lectures are educational malpractice. I think that anybody who has to sit through one should ask for their money back. But it's not just social things. Your brain is actually actively hurting you when you think through some of the things that you should do. There's a really cute brain on this slide. There you go. All right, your brain is lazy. It's really lazy. It's called the cognitive miser hypothesis. If your brain doesn't have to work, it probably will try not to, which is funny because your brain also thinks that it's really smart. There's something called the illusion of explanatory depth, where if I asked you guys if you know how a bicycle works, everybody's like, yeah. And then I'm like, write it down. I'm like, well, shit. So you actually think you understand way more than you really do. And the last thing, which Krishna talked about before, is that your brain really likes its own ideas. So this is confirmation bias. Your brain loves things it already knows. So your brain is lazy. Your brain thinks it's really bright, and it thinks it knows all that it actually needs to. And all of those work against us from making good choices about how to engage with information so that we actively learn it. If you think about trying to handle an LLM or a social interaction, most of what we're doing is input, something hidden, magical happens in the middle, and then there's output. And so in a teaching context, that input might be something like, teach me about cell signaling. This is something you could reasonably ask of an educator. And so they would have some sort of hidden nodes inside of their brain, and you would generate output. And it is typically somebody who is standing in front of you telling you things about cell signaling. You can do the same thing with an LLM. Teach me about cell signaling. The hidden nodes look a little bit different. Philip did a really beautiful job of talking about the space that a large language model actually inhabits. So it's taking each one of these words and trying to predict a response with the words in the middle. And then the output looks something like this. This is literally from ChatGPT about an hour ago. So if you say, teach me about cell signaling, you get a lecture. You get like a freaking wall of text. But the challenge here is that the problem is not the output. The problem is the input. We asked for something very lazy when we could have asked for something much more intelligent. And whether it is a human trying to teach you something or an LLM trying to teach you something, if you give it better input, I promise you will get better responses. So all I've done is change the prompt to be slightly more specific and say, be the best active learning facilitator ever. Help me learn something about cell signaling by asking questions one at a time and critiquing my responses as we go. You get your hidden nodes. And ChatGPT says, great, let's dive into cell signaling. First question, what is it? Why is it important? Take your time, answer, and I'll provide feedback afterwards. So this is going to provide you with a way more structured experience to really dig into it and not let your brain do the lazy thing, which is read a wall of text and be like, I've learned it. So when we come back to these 3 things that your brain doesn't do very well, instead of letting it be lazy, ask LLMs to ask you questions. I do this all the time. I'm like, I want you to revise this proposal for me, but before you do that, ask me 5 questions that will help you do a good job. And what that turns it into is a thought partner. It makes me think. It doesn't let it do the thinking for me. The other thing you can do is ask it to break down your response. So if you think you understand how something works, say, ask me about this process step by step. So then you're actually pushing on this idea of getting over the illusion of explanatory depth. And then my favorite is asking it to disagree. Academics write papers and then they want to send them to reviewers so that they can get published, so they can get mini famous in their tiny little niche. And the best thing to do with a paper is not ask an LLM to write it for you. It's to say, imagine you are the world's worst reviewer. I want you to critique all of my ideas and tell me how to make them stronger. So what you're doing is you're just changing the input and you're going to get much better output. If you want more, I'll plug Stephen's book. He comes to these sometimes. He's wonderful. He was my former boss. He wrote a book about active learning with AI. And so it goes through 5 different principles of active learning. Let's see if I actually know them off the top of my head. I don't, so we're going to skip it. You can ask me later. Chunking, make associations, make sure you use deep processing, deliberate practice, and another D. I know the acronym. But the idea here is he writes about each one of these principles of learning. There's as many as you want there to be. He picked 5. And then says, here's how you can use AI with students in a teaching capacity to create lessons that will actually engage them so it sticks, and you can just apply that to your own self-learning. So the picture I kind of want to leave you with is we want our experience of what we think learning is to kind of be like riding on the Eurorail. We want it to be smooth, we want it to be beautiful, we want to sit there and let somebody tell us something. And that's just so wrong, because what is really going to help you learn is going on a road trip where the signs are confusing, everybody's switching, who's driving all of the time, and you're really trying to engage with the map, what's happening, what your goals are, and thinking about where you've been. So instead of smoothly flying through your experiences whenever you try to learn, try to make it as messy and failured as possible so that you actually remember all of the things that you intended to learn in the first place. And that is the end of the talk.